So I'm going to go through quickly how to calculate compounding interest, which will apply in other exponential growth situations, but we'll start with a very basic situation of putting money in a bank account, and it earns interest, compounded annually, and we'll talk a little bit about that too. First, some terms. Remember that we're going to have to deal with T, which is time, and this time we're going to be talking about is in years. Okay, we're going to be introducing P, which is principal, and principal, whether you're talking about a balance on an account or a debt, whether it's a deposit account or a mortgage debt or a credit card debt, the principal is the amount used to calculate the interest, so it's what you have before interest. Okay, and then R is going to be the interest rate. Okay, so that's usually given in a percent, whether it's a decimal percent or not. It doesn't matter. For the rate is the interest rate, R. Okay, we're going to start with a basic situation of a bank account, and we're going to, let's say we put $1,000 in the bank, and it's going to earn 6% annually. So every year, we're going to add 6%. We're going to find out what 6% is of whatever we have in the bank, and we're going to add that to our principal. So first, definitions, P0 is $1,000, okay? Because P0 means the principal after no time has passed. On day one is called year zero, okay? Now, to find out what we have after 1 year, P1, we still get to keep our $1,000, of course, plus we get the interest, which is $1,000 times 0.06. Okay, so we have $1,000, I'm going to put another equal sign, $1,060. So P1 equals $1,060. I'm going to dispense with the symbols in the decimal pretty well. I'll need the decimal. But, okay, so that was easy enough, right? But how do we find out how much we get to have after a second year has passed? Well, we obviously get to keep our $1,060 from last year, plus our new interest, which is 1,060 times 0.06. Okay? And 1,060 times 0.06 is 6360. So we end up with, where am I? Here we go. $1,123.60 is P2. Okay. Now P3 will be the same process. It'll be our P2 plus the interest on P2. Which is $67.38. And we end up with a balance after 3 years of 1,100. That's not right. Yeah, 1,190 and 98 cents. Okay. Now, let's look at this from a more abstract point of view. We knew that P1, we took P0 and added P0 times R. Okay? Our starting principal plus our starting principal times the interest rate. So after 1 year, this is what we have. Now, if we look at this from an algebraic standpoint, we have this P0 in both terms, and we can factor that out as P0 times 1 plus R. since P0 times 1 is P0, and P0 times R is P0R. Okay, so we need to remember this, that P1 is going to be equal to P0 times 1 plus R. Now P2 is going to be the same process, except it's P1 plus P1 times R, which again can be factored. It's P1 times 1 plus R. And we know from just a second ago that P1 is equal to P0 times 1 plus R. So we end up with P2 equaling P0 times 1 plus R, which is the same as P1, times 1 plus R, which ends up being P0 times 1 plus R squared. So P2, our balance, our principal, after 2 years, is going to be our balance to start with, P0 times 1 plus the rate, to 1 plus whatever our rate is. In this case, it was 6% or 0.06, raised to the power of the year that we're talking about. So P3, again, if we wanted to break it down, it's going to end up being P2 plus P2R, and P2, so it's going to be P2 times 1 plus, I'm going to erase that, do that again. One plus R, which in P2 we already figured out was equal to P0 times 1 plus R squared. So we've got P0 times 1 plus R squared times 1 plus R again. So P3 is equal to P0 times 1 plus R to the third power. That rule will always apply if you know. So for instance, we're looking at our account. Let's say we want to find out how much we have in our account after 22 years if we started with $1,000. So 1,000 equals P0. Our interest rate is 0.06. And let's say we want T equal to 22 years. Our balance, our principal, so our P at 22 will be equal to 1,000. P0 times 1 plus R to the 22. So it equals 1,000 times 1 plus 0.06 to the 22nd power, which is equal to 1,000 times 1.06 to the second power, and what that ends up being equal to, and after plugging it into the calculator, is $3,603.54 after 22 years. In general, PT equals P0 times 1 plus the rate raised to the T power. So depending on how many years it takes. Hopefully that'll help you, and that's enough of that.